back to Science Kids of Martin County. Before we start today's show, I would like to extend a great big thank you to Martin County Education Foundation for helping to support our science tools and materials that we use on the show. I would also like to thank the Martin County Board of Commissioners for producing this program. As you see, I have this really cool suit on. Can you make a guess on what you think our topic is going to be about? Yes, today we're going to be talking about objects in space, like the Earth, the Moon, and the Sun, and how they work together. The reason we're going to be talking about these objects in space is because we have some pretty amazing things happening in August. The night of August 12th and early morning hours of August 13th, the weekend before school starts, we're going to be able to see a meteor shower and at its peak. Many refer to these as shooting stars. On Monday, August 21st, another amazing thing is going to happen. Something that hasn't happened since almost 40 years ago. We're all going to experience a solar eclipse in the late afternoon. So let's get started by getting to meet our two scientists for the show today.
Hi, I'm Summer.
Hi, I'm Talon.
Okay, so before we get started, I have some really awesome jokes to tell. Are you ready? Okay. How do aliens get their babies to sleep?
I don't know.
They rock it! Okay. How do you know when the moon has had enough to eat?
It's a full moon.
When it's full. Good job. Couldn't trick you on that one. All right. What time do astronauts eat?
I don't know.
At lunchtime. All right, stay tuned as we get prepared for our objects in space. All right, welcome back. So right now we're going to take a quick minute so I can explain what meteoroids are and what this meteor shower that we're going to be seeing is all about. So in outer space, we have lots of flying objects. We have asteroids, we have meteoroids. And what happens with a meteoroid is it's actually just a smaller version of an asteroid. Some of the materials are different as well. But what happens is a meteoroid sometimes tries to come through our Earth's atmosphere. Now our Earth's atmosphere is just hot burning gas as well. So typically what happens is when those meteoroids come through our Earth's atmosphere, they catch on fire and they just blast apart. Sometimes, and that's when we actually see that shooting star. That meteor shower that you're going to be seeing is those meteoroids coming through our Earth's atmosphere. Now some of them will actually make it and hit our Earth's surface. And when they do, that is at that point they're called a meteorite. So it goes from meteoroid to a meteor to a meteorite. Now, if the meteoroid makes it through our Earth's surface and hits it, and it's called a meteorite, what is it called when it misses our Earth's surface?
A meteorite?
So with a meteorite, when it hits our Earth's surface, so what is it called when it misses it?
Meteoroid.
Good guess. A meteor wrong. I'm so funny. Get it? It was a joke. So it really is nothing. So if it doesn't come through, it's your meteor and it's done. So we actually have meteorites hitting our schools, our buildings, and all the time. But by the time they actually hit, they're just so small, we don't really hear it or feel it. But you can actually find it if you have those metal detectors out there. Okay, so we're going to go ahead and move on and talk about how our sun, our moon, and our Earth all work together. So how we get this really cool solar eclipse. So the first thing we're going to talk about is our sun. Can you guys tell me anything and everything that you know about the sun?
It's a big ball of gas.
It's a big ball of gas. It sure is. The sun is not a planet. The sun is a
Star.
It's a star, absolutely. So our star sun is very important to us, and it appears to be so big and so bright because of how close it is. The star sun is the closest star to Earth. It is not that big, actually the biggest star that's out there. There are many stars that are bigger than our star sun, but because it's so close to us, it's why it appears so big. The first thing I would like to talk about is the shape of a star. So a lot of our younger friends, our kindergartners, first graders, they appear to think, because we always talk about, let's draw stars. And they usually draw these stars the shape of this, our 5-point stars. So these stars are fun to draw, but this is not what our stars look like in space. Our stars in space are what?
A circle.
They're a ball, they're a sphere, absolutely. So obviously this is a circle, but it's more of a sphere where it has that 3-dimensional figure to it. So this is more of our pattern, our math star. Our science star is actually a sphere. It's a big ball of hot burning gas. Okay, so the next thing we're going to talk about, our star, is the size of our star sun. So I've made a little model here. Isn't that fun? M&Ms. Using food for science is always a great way to go. So here we have, this is going to resemble our moon, where it's the size of 1. Our Earth is actually 4 times the size of the moon. So our Earth is bigger than the moon. So that's why we have 4 M&Ms. Now our sun, the star sun, is 100 times larger than the moon. So you can actually understand that if the moon is 1 and the sun is 100, the sun is much larger than our moon and much larger than our Earth as well. Okay, so the next thing we're going to talk about is our temperature and the colors of the stars. So here we have our stars, and as you said, they are spheres, and these are actually different colors that stars come in. When we look into our night sky, all the stars look the same color because that's how far they are. But if you actually got to see stars up close, they are all different colors. And the colors actually depend on the temperature of the star. So do you guys know a little bit about the temperatures and the color of stars? Would you like to explain what you know?
Some people think that like the yellow is like, or the red is like the hottest, but really like the blue is the hottest star of them all.
You're absolutely right. Talon, do you have anything to add, or are you kind of right on where she's at?
I'm right on where she's at.
She's right on. Absolutely. So a lot of us, we think because the sun is so hot to us that yellow is hot. But what really is, and then we think of red as hot, fire, it's really hot, but it's not. Your red star is actually the lowest temperature type star. Blue stars are our hottest temperature stars. It's kind of like a fire. If you were to see a flame, the hottest part of a fire is that inside that blue part of your flame. It's still hot on the outside where it's red and yellow, but that's actually its lowest temperature of that flame. So knowing your least to your highest temperature is important as well. So if you see our star is a yellow, our star sun is yellow, it's actually a medium temperature sun. Okay. Now this part I think is really cool too. Next we're going to talk about the distance of our stars. Now when we look into our night sky, a lot of our stars, some of our stars I should say, look like they're brighter than others. But that doesn't necessarily mean that they're bigger or that they're a hotter temperature. It depends on all of them. It depends on the size, the temperature, and the distance of the stars from where we are on Earth and how we see them. So to kind of show you what I'm speaking of, I have a few pictures here. So somebody is taking the picture of the elephants here. These are all adult-sized elephants. So you can see that this elephant here is closest to the photographer. So it appears big. These elephants are further away. So even though they're the same size elephants, look how little cute and tiny he looks because he's so far away. The next example here, I have some hot air balloons. Now all hot air balloons are typically the same size. In this picture, they are all the same size balloons. So my question to you guys, which balloon is closest to the photographer?
That one.
The red one that shows the biggest.
How do you know?
Because
it looks the biggest.
Because it looks the biggest. So it's the closest one to the photographer, therefore it's going to look bigger. So stars that are closer to us are going to appear to be bigger. Now, which one would you assume would be the furthest away?
The small one in the background.
Now, why would you say that?
Because it looks really,
It
really
looks
small.
really
it
small
looks-
compared to them.
Absolutely. So the further away objects are, the smaller they're going to look. It doesn't necessarily mean that the size is changing. So it's a really interesting concept to try to talk to our kids about, is understanding when you're looking at the stars that the bright ones doesn't necessarily mean that they are bigger or that they're any different. It's just because of the distance and how far away they are from where we are on Earth seeing them. All right, I got this one last picture to show about distance, and I think this one's really exciting. So here we have an amazing picture of a beautiful sunset and a picture of a bird. Now, as you see in here, the bird actually looks like it's larger than the sun, and that's just not possible. Actually, if you understand, as we said, that the sun is 100 times larger than a moon. So, again, as you see, the closer things are, the bigger they're going to appear. The further away things are, the smaller they may appear. Okay. Stay tuned as we start talking about our Earth. All right, welcome back. So we just finished talking about our star sun. Now we talked about how our stars are big balls of burning gas. So because of the burning and the gas it produces, our stars produce light energy. So our star sun is what gives our planet Earth our light. So therefore, we actually see light during the day, and at nighttime we don't have as much light. Do you guys have any idea how we would be able to explain to our friends out there how we get day and how we get night?
Well,
Hold on one second. Actually, what I'm going to do is here I have one of our friends here, and I'm going to put us right on North America so you guys can actually see where we are, the United States. And I mean, he's a little bit bigger than Florida, but that's all right. We can get the point. All right, go for it. Tell me what you guys know about day and night.
So right now, how he is, it's like we're like in really early morning, but when we're going around, our Earth is also rotating while we're rotating around. So like when we rotate around to a certain point, we're gonna get our day. But when we rotate around to another point, we're gonna get
night.
our night. So after we rotate a 24-hour rotation, we have our day and night.
Okay. So you're saying when you rotate, when you're going around this one big time, that's how we go from day and night. Okay. Great thinking, guys. So actually what happens is, if you guys want to know, this is actually our moon, but I'm going to take our moon off because when we're talking about day and night, our moon really has nothing to do with day and night. So what happens is that we have our star sun, right? We're going to go ahead and start in the daytime. While our Earth, we are turning right now. We are actually spinning. Every hour our Earth turns just a little bit more. So we actually stay right here. And when we are pointing towards the star sun, that's when we're having daytime because we're getting the light energy from the sun. Now, if you watch our fun little dude here, we are going to be spinning, we're going to rotate, and it takes 24 hours. So you were absolutely right. It does take 24 hours to rotate, but we do one spin right here. We do one rotation right here. Now, as you see, our friend here is away from the sun. The sun does not move. We move. Every hour we're moving just a little bit more. So now it's dark time, nighttime. We are not receiving any sunlight. We are not receiving any light from the sun. We keep going. So this might be like midnight, and then it's 1 a.m., 2 a.m., 3 a.m., 4 a.m., 5 a.m., 6 a.m. Well, now we've got a little bit of starlight happening. We have a little bit of sunlight happening. So you're starting to wake up. I mean, maybe not our teenagers here, but we're starting to wake up. So we're moving a little bit more, and the sun's getting brighter and brighter and brighter and brighter because we're moving closer and closer and closer to where we're getting those sun rays from. It happens in a 24-hour period. That's one day, right? So we're going to make one rotation, one 24-hour period. How many days are in a year?
365.
365. Am I keeping you up?
Yeah.
You're not enough. You need it's daytime. Wake up. All right. So we are going to actually get 365 day and night, day and night, day and night, day and night. So we are constantly getting day and night the entire time. So when you're doing your day and night and day and night and day and night and day and night and day and night 365 times, that's when you get to scream, Happy New Year, right? So I do a little thing in my classroom where when a kid tells me it's their birthday, we get really excited because I tell them, oh my gosh, that's so exciting. So we sing a song. Instead of saying happy birthday to you, I say, congratulations to you, congratulations to you. You revolved around the sun, congratulations to you. So when you go through your entire year, 365 days, you get to celebrate another birthday, or you get to scream Happy New Year. But your day and night happens in one spin. But you spin 365 times to get 365 day and nights to get to have another birthday. Isn't that fun?
Yeah.
Mm-hmm. So, correction, I want to make sure you guys understand. So you're not making one full trip around the sun every day. You make 365 days and nights get one trip around the sun. Cool?
Yes.
All right. Stay tuned as we start to move on to our moon. We're back. Thanks for joining us as we start talking about our phases of the moon. Now, when we're talking about the phases of the moon, it all happens with our star sun, where we see things on Earth and the moon. Now, here we have two things that we're going to be using to show our moon. Here we have my cool pink ball, and then here we also have another image of the moon. What I want you to really understand is our moon is also a sphere, just like our star sun is a sphere. Our planet Earth is a sphere. This here is going to show you that it looks like this. We're only going to be focusing on this part. So I'm going to put this to the side because I really want us to understand and see how our star sun provides our moon basically with a day and night, just as our star sun provides our planet Earth with that day and night. Okay, so Talon here is going to hold our pink ball here up to our star sun. And as you can see, that only this side of the pink ball, this side of our moon, is getting the light. When that part we can see it completely covered, that's going to be our full moon. Now the motion that our moon makes is it actually starts to move around our planet Earth. So if we were here, and then the moon would be moving around. So he's going to go ahead and spin.
I thought the moon moved this way.
It does. So that's what I was saying. So if my Earth was here, you're absolutely correct, Summer. Great job. So what I'm meaning is it's kind of going to be going around.
Okay.
Right. So our Earth is spinning like this, while the moon is spinning like this. Very nice. Good job. Okay. So it actually takes about 29 days. It takes a month for our moon to make one full circle around our Earth, just like it takes 365 days for our Earth to make it around the sun. So there's lots of movement going on. Our Earth is moving, our moon is moving, and it's all moving and orbiting around the star sun. So we're getting close to seeing how this amazing solar eclipse is going to happen. So if you focus again on our cute little smiley face, is going to be here on the light, and as Talon turns it, you can see it's not getting light from the sun. And that's why, now go ahead and stop there. So if our smiley face is here, there's no light reaching. The sunlight is not reaching this part of our sphere, this side of the moon.
So that means it's a new moon, right?
Correct. So if we were here looking at it on Earth, we would not see the moon at that point in that phase. So again, the reason why we see different phases of the moon is because different parts of the moon are getting illuminated, are getting that sunlight. Great job, thank you. All right, so actually I'm gonna have you keep holding on to here. Now, Summer is going to show us what the phases of the moon look like. So right now, there is no part of the moon that is being illuminated from the sun, which means it would be completely, this side of the moon would be away from where the sunlight is happening. All right, Summer, go ahead and, there we go. Okay, so every night the moon starts to change its shape a little bit, but the moon's not really changing shape. What's happening is different parts of the moon are being illuminated. So this would be showing that the light from the sun is hitting just this part of the moon. Go ahead. Night again. All right, oops. We can't go back one. So what would happen is a lot of our kids say, oh, it's a half moon out there. But what is it really called?
Third quarter.
Okay, you're almost there. You're absolutely right. So it would be a quarter moon. Now we have a first quarter and we have a third quarter.
Third quarter.
Or we can say first quarter and last quarter if you don't want to say third. First and last. So if you see how on the left side it's illuminated, that would be our last quarter. Okay, go ahead and keep going. Another night. Now we have the full moon, which means it's completely turned, and then it starts all over again. Go ahead. One more. Stop. Okay, so now we're back at that half moon, but now it's illuminated on the right side, which we would consider would be the first quarter of the moon, and then the cycle continues to happen. All right, we're going to go ahead and get our supplies ready for a little art project. Parents, if you would like to go ahead and pause your TV screens now and you can join in and get our materials, that would be great. Okay, so the materials that we're going to be needing for this project that's going to help us explain our phases of the moon and how we're going to get this amazing solar eclipse. You are going to need your white piece of paper to draw on. Look at you guys, very nice. And we're going to need 3 different size circles, okay? So we're going to, something that will be the size of our sun, very nice, and our earth, and then your smallest will be your moon. We're also going to need a green, a black, a blue, and a yellow. Are we ready? All right, so the first thing I want you guys to do is we're going to go ahead and take your plate. You're going to put it on the edge of your paper. You're going to take your yellow. Go ahead and trace that in.
Sorry. Got it.
Wonderful. Now we're going to go ahead and take your medium-sized one, put it on your plate. Make sure you leave some room because your moon is going to be orbiting your Earth. Make sure you leave some room. You're good? Okay. Take our black and we're going to go ahead and make 4 circles. One that's going to be right here in the middle, directly between our sun and our earth. One right below. One all the way to the side. You guys are like, Miss Brownie, what are we going to do? Oh boy. There we go. All right. We're going to take some time. We're going to go ahead and color these in. All right, so now go ahead and grab your black. This is going to help us to draw our line in between. Now remember when I told you guys when we had our pink ball and we had our star sun and half that moon was getting illuminated because of the light and the other half was not? Well, that's basically what we're going to show here. So we have a flat diagram here but to help us understand. We're just going to draw a line right in the middle of each of our circles here, okay? Because only one, if these are our sun and our earth, and this is our moon, right? So the sunlight can only get to one side, so watch this fun stuff. So here's our sun, and it's going pew 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 pew. All that light's going crazy, yeah.
Oh yeah.
Pew, 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 pew.
Oh yeah.
It's just giving all those rays, and that's which way it's going, right?
Shred the gnar, bro.
There it is, absolutely. My picture's so on fleek, right?
Oh yeah.
Yep, I got that.
Oh, sorry.
No worries. All right, so what we're paying attention to, remember, only one side of the moon is going to get the light, right?
So
if the sun is here and it's going pew, 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 what side of our moon is getting the light over here?
This side.
You got it, gets close to the sun. So we're actually gonna black out that right side here. Oh, all right. You guys are already ahead of me. Absolutely. So again, our sun's going pew, pew, pew. So this side of the moon over here is getting all the light, therefore this side is not. So I'm gonna black out this side. Same thing here. Now the sun's going pew, pew, pew. So the light's getting all over here. So that means this side does not have any light. Same thing here. This side is not receiving any light. Now, this is, we're going to draw it because our moon, as our Earth is going, choom, choom, turning this way, our moon is going this way.
Okay.
This is you on Earth.
Got you.
Go ahead and draw you on Earth. You can be anywhere you want.
I'm in Africa.
Cool.
I'm in the ocean at the
There
bottom.
it is. All right, well, hopefully you have your scuba gear. All right, so here what's happening is, it's as the moon is moving, we see the moon appear in different ways. But again, it doesn't change. The half of the moon doesn't fall off at different times of night. It's all still there. It's a different part of lit up. So if you're here and you're looking at the moon, right, and you see this, what do you see?
You see
So if you're here and you're looking here, what do you see?
New moon.
You see new moon because you see no moon. No moon is new moon. So we're going to write new. On August 21st, when we're having our solar eclipse, that night we will be having a new moon. The moon is going to be right directly in between the sun and the earth. Now what's also going to happen is this is actually how we're getting our solar eclipse as well. Because our moon is during that time of day, and because of the distance of the sun and the distance and everything just is perfectly aligning together at approximately 3 o'clock that afternoon, we're going to experience darkness, a portion of darkness where we are. And because the moon is going to actually block the sunlight because of the position being right there. So we are going to have a new moon that night, but in the afternoon, because everything is perfectly aligning, that is how you're going to be getting your solar eclipse. All right, moving on. So as the moon keeps moving day and day, next day, next day, next day, so what happens is we're going to be, if you're here on Earth and the moon is here, what do you see?
A quarter moon.
Absolutely, right? So you see,
Last or
It is a-
third quarter. Last.
right, so it's on the left, right? So this would actually be your last quarter or third, sure. Wait, hold on. I think that's, sorry. Because you're here, right? So the darkness is going to be on there. So this is actually your first quarter.
Oh, darn it. Fixed it.
And then you're going and you're going. And now look, you're here and you see. What do you see?
Full moon.
The full moon.
Right. So you can even draw yours to see. What do you see? It's all lit up. So that's going to be your full.
So then that means this would be your third or last.
All right. So now we're looking this way. And then we have it all lit up on one side and darkness on the other. And this is going to be your last quarter. Your last quarter is illuminated on the left. And then it starts all over again. So because our Earth is spinning, our moon is moving, and our sun is giving us energy, as the way it's perfectly aligning, that's how we're going to be getting our solar eclipse on August 21st. It's going to be amazing. Make sure you're wearing your safety solar eclipse glasses because it's very dangerous. As we know, a lot of us wear sunglasses to protect us from that star sun. During this period, you're going to want to really make sure you have your solar eclipse glasses on. Okay, do you guys have anything you'd like to say before we end our show?
No.
Nah,
Except how awesome this was?
Yeah.
it was amazing. It was fun.
Awesome. All right, well, thanks for joining us, and we'll see you next time.